Hi everyone! The goal of today's video is to learn how to describe motion verbally and graphically. First, let's talk about some important vocabulary terms. Distance is an important term which is a scalar quantity. It describes how much ground an object has covered. It has always a positive value, and it is different from displacement. Displacement is a vector quantity. It's object's overall change of position, and it describes how far out of place an object is. Here's an example of distance versus displacement difference. A teacher starts walking 3 meters north, then 5 meters east, 3 meters south, and 5 meters to the west. So what is the distance that the teacher covers? Yeah, the teacher covered 3 plus 5, 8 plus 3 plus 5, 16 meters. So the distance equals 16 meters. What is the displacement that the teacher has? Okay, correct. Displacement is 0. The teacher returned to the same position that she started with. So the change of position of the teacher's motion is 0. So displacement equals 0 meters. That is the difference. Speed is a scalar quantity. It's a rate at which an object covers a distance. It obviously determines how fast you're going, and it's always a positive value. Whereas the velocity is a vector quantity. It's the rate of change of position or displacement over time. It also describes how fast you're going, but it's a vector quantity. It includes direction, and it can be positive or negative. The formula for average velocity is displacement over time, d over t, or change of position over time. Acceleration is another important term. It's the rate of change of velocity, and as you might have guessed, it's also a vector quantity, since velocity is a vector quantity, and it describes how fast the velocity is changing, or how fast you're changing speed or direction. It's a vector quantity, and it can be positive or negative. The formula for acceleration is change of velocity over time. Let's describe motion. Before we look at some examples, we want to first ask questions when we start describing motion. For example, is the object at rest or moving? If it's at rest, you're done. You just say the object is at rest. If it's moving, what kind of motion is that? Is it motion with constant velocity or with acceleration? And what direction is the velocity? What direction is the acceleration? Let's look at scenario 1. A soccer player is running at top speed towards the goal. Is the object at rest? No, it's obviously moving. So what kind of motion is that? Since it's saying at top speed, we can assume it's moving with constant velocity. So these are the questions on the top right for you to consider, and this is the example of the answer. The soccer player is moving at a constant velocity in the positive x direction. Please pause this video and describe the motion for the scenario 2 on the Google form. Okay, let's continue. Relative velocity. Relative velocity is the overall velocity relative to a reference point. For example, if you are in a car on a highway and there is another car on your left moving with exactly the same velocity as you may say that the car is not moving relative to your car or relative to where you are at. So in that case, the relative velocity of the car is 0 relative to your car, but it's not 0 relative to the observer staying on a highway or on the side of the highway. So let's look at this picture. It's a jet ski and the tube that is behind jet ski, the water tube. Let's look at this example. What's the relative velocity of the jet ski to the tube? So relative velocity of the jet ski is indicated with vector j, and the velocity of the tube with vector t. We have to add this head to tail, adding two vectors. We can see that a vector j and vector t will add up, and the relative velocity will be equal to 0. So the tube is not moving relative to the jet ski. Okay. In the second example, we have a jet ski moving with the velocity of 8 meters per second, and in the still water, and the water's current, the river, moves with the velocity 3 meters per second. So what is the relative velocity of jet ski to the shore? So we want to add the two vectors, the velocity of jet ski in the still water and the velocity of river's current of water. So we're going to have j plus r, the velocity of river, which is 8 meters per second plus 3 meters per second equals 11 meters per second, is the relative velocity of the jet ski to the shore. Now pause this video and answer the question number 3, if the jet ski's maximum speed is 8 meters per second in still water. So we're using speed and velocity here interchangeably because it's a straight motion, and the river travels 3 meters per second. What's the relative velocity of the jet ski to the shore when traveling in opposite direction? So please pause this video and answer the Google form. Graphs of motion. We are going to talk about two different graphs. First is position versus time, and the second is velocity versus time. So here we have a position versus time graph. Position always will be the y-axis, and second word in the title always will be x-axis. So position, time. So here you can imagine a football player starts with the 10-meter mark. Then for 2 seconds it stays in place. Then in 2 seconds it covers the distance of 10 meters towards the origin, and then stays in place, and then continues in a negative direction, stays in place, returns to the positive direction, and continues in a positive direction. So let's look at the motion between B and C. Remember that the V, by definition, the average velocity, is displacement over time. So let's look at the displacement between B and C. Remember, displacement is the change of position over time, delta x over t. So we can see that the delta x is x final minus x initial over t. So what's the x final? This is the point C, which is 0 meters, minus what's the x initial? It's 10. It's point B, 10 meters over 2 seconds. It is going to be negative 5 meters per second. That is the velocity between B and C, negative 5 meters per second. You can also say that this is the vertical distance divided by horizontal time, which is delta x over t. So you can say that it's also a slope, right? The definition of the slope is the rise over run. This is what we have here. So the important part of this graph is that the slope of the position time graph represents velocity. So what if the object moving with acceleration? So with acceleration, it will be a curved line. For example, it will be something like this, a curved line. What is the instantaneous velocity for the accelerated motion? Well, any point of the curved line, we can find the velocity by making a tangent line. So the tangent line to the curve is going to be the slope of this tangent line to the curve is going to be the instantaneous velocity of the object at this given point of time, which is here. So to summarize, the average slope between 2 points is equal to the average velocity for the distance versus time graphs, and the tangent slope is equal to the instantaneous velocity. So for this example, we're looking at the velocity time graph. So velocity is going to be on y-axis and time on x. And very similar to the previous graph, displacement versus time, we can say that the slope of the line is going to be the acceleration, because acceleration is the rate of change of velocity. Remember, acceleration A is delta v over t, and it's going to be v final minus v initial over t. So let's look at this example here. So from 0 to 2, for first 2 seconds, what's the acceleration? Velocity is changing from 0 to 20 meters per second. So let's look at the rise over run. So the rise will be 20, or v final will be 20 meters per second minus v initial 0 meters per second divided by total time of 2 seconds, which is going to be 10 meters per second squared. That is going to be the acceleration for this area. I mean for this first 2 seconds. So how about the displacement? We can find displacement from this graph. And remember, displacement, if we rearrange the velocity equals displacement over time formula, displacement is going to be velocity times time. So when we look at this graph and we want to know what is the displacement between 2 and 6 seconds, for example, we can say that displacement at velocity, which is this, the y-axis, times time, which is this, the x-axis. So if you multiply velocity times time, which is going to be, in our case, 20 meters per second times, what's the time? 6 minus 2 is going to be 2, 4 seconds. It is going to be 80 meters. We can see that seconds cancel out. So 80 meters is the displacement. So the area under the line here or curve is the displacement. So I want you to pause this video and answer the following questions. I want you to find the displacement between 6 and 10 seconds using this graph. I want you to find the acceleration between 8 and 12 seconds using this graph. And I want you to find use the first graph and to find the velocity between G and H. Between G and H, find the velocity. Thanks for watching.